Hello, dear learners, and welcome to this presentation of a lesson in mathematics at high school level. My name is Makuvalo Frederick, and in our lesson today, we are going to look at the topic algebraic fractions. Specifically, we are going to consider the addition and subtraction of algebraic fractions. At the end of this lesson, you should be able to carry out addition and subtraction of algebraic fractions without difficulties. Let's now move on and get into the details of the lesson. Before we go into adding and subtracting of algebraic fractions, let us consider two cases of common fractions so as to refresh our minds. The first one is 2/5 minus 1/3. I hope you recall from as way back as primary school that whenever you are subtracting two fractions, the first thing you need to do is to find the lowest common denominator. So in this case, what do you think is the lowest common denominator? Good. 15 is going to be the lowest common denominator. But when we look at our two denominators, we are going to see that 5 is a prime number. 3 is also a prime number. Just in case we have forgotten what prime numbers are, a prime number is a whole number that has exactly two factors, meaning 1 and the number itself. For example, when we look at 5, the only other two whole numbers that can be multiplied to get 5 are 1 and 5 itself. There are no other two whole numbers that can be multiplied to get 5. And the same applies to 3. So when you have a fraction and it so happens that the denominators are prime numbers, the lowest common denominator is simply the product of the two prime denominators. So it is going to be 5 multiplied by 3, which will give us the 15. Okay. So now we proceed as is always the case. The first denominator into the lowest common denominator, we will get 3. And this 3 is going to multiply the numerator, which is 2. Minus the denominator 3 into the lowest common denominator, which is 15, will give us 5, and will multiply the numerator, which is 1. Then after this has been done, it will be a question of simplifying the expression. And we know that 3 multiplied by 2 will give us 6. Negative 5 multiplied by 1 will give us negative 5, divided by our lowest common denominator, which is 5 times 3, and as we earlier said, this will give us 15. In the numerator, 6 minus 5 will give us 1. And of course, the denominator is 15. And remember, every time you find the answer for a fraction, you must ensure that the fraction has been reduced to its lowest terms. So when we look at 1 and 15, we do not have a common factor. Hence, this is going to be our solution. Let's now look at another situation where the two denominators will not necessarily be prime numbers. And here we are. we have 1 over 6 plus 3 over 10. Like I said, when we look at 6 and 10, we are going to appreciate that the two are not prime numbers, because besides 1 and 6, there are other two numbers that can be multiplied to get 6. So now, let's look at another situation where the denominators are not necessarily prime numbers. We have 1 over 6 plus 3 over 10. And like I said, 6 is not a prime number, just like 10 is not a prime number. So the first thing you need to do is to express the two denominators as products of their prime factors. Meaning, you find the prime numbers, which when multiplied will give you 6, and which when multiplied will give you 10. So let's start with 6. Which prime numbers can we multiply to get 6? Indeed, the two are going to be 2 and 3. So this fraction 1 over 6 has to be written down as 1 over 2 multiplied by 3. And the same thing has to be done to the denominator 10. If you have to think about the two numbers which are prime, and when multiplied will give you 10, you will realize that the two are going to be 2 and 5. So this second one will be expressed as 3 over 2 multiplied by 5. When you now look at these two denominators, you are going to see that in the second case, we have a repetition of a factor which is appearing in the first one. So when doing the multiplication, like what we did in the first case, we are going to avoid repeating factors in the second denominator which are already appearing in the first one. So the lowest common denominator is going to be the product of these two, these 3. In the second one, the 2 is going to be a repetition of the first one, meaning we are going to only include 5. So in this case, the lowest common denominator will be 2 multiplied by 3 multiplied by 5, which gives us 30 as the lowest common denominator for 6 and 10. Then we proceed. When the denominator 2 times 3 is divided into the lowest common denominator, the result is going to be 5. And this 5 is going to be multiplied by the numerator, which is 1. Plus, when the denominator 2 times 5 is divided into the lowest common denominator, the result is going to be 3. And this 3 is going to be multiplied by the numerator there, which is 3. Then we will proceed as was the case before. 5 multiplied by 1 will give us 5. Positive 3 multiplied by 3, this is going to be 9 divided by. The product 2, 3 and 5 is going to be 30, like we stated earlier on. Then in the numerator, we are going to have 14 divided by 30. Like I said, every time you must ensure that the fraction is reduced to its lowest terms. So when we look at 14 and 30, we are going to appreciate that there is a common factor of 2. So in the numerator, we divide by 2. Whatever we do to the numerator, we must be able to do to the denominator. So 14 divided by 2 will give us 7. And 30 divided by 2 will give us 15. And this is going to be our simplified solution. In our example, we are going to look at how we can express 3 over a minus 5 plus 4 over 2a plus 3 as a single fraction. We will need to do just like what we did for common fractions. We have to look at the two denominators. In this case, it is not going to be seeing whether they are prime numbers or not, but we have to check whether a minus 5 can be factorized and whether 2a plus 3 can be factorized. So let's look at the two denominators. Given a minus 5, we are also given 2a plus 3. Are we able to factorize them? When you look at them, you are going to see that it is not possible to factorize them. So the two of them are going to be treated like the way we treated prime numbers. So the lowest common denominator in this case is simply going to be the product of this denominator and this other denominator. So it will come out as a minus 5 multiplied by 2a plus 3. Then we are going to proceed. We take the first denominator divided into this lowest common denominator, and we are going to appreciate that when that division is done, the result is going to be 2a plus 3. So the 2a plus 3 must be multiplied by the numerator 3. So we are going to have 3 multiplied by 2a plus 3. The second denominator, 2a plus 3, when divided into the lowest common denominator, the result is going to be a minus 5. So positive 4 must be multiplied by that result, which is a minus 5. Then there will be need for us to expand the numerator and simplify. So we proceed. 3 on 2a, the result is going to be 6a. 3 on positive 3, the result is going to be positive 9. Then we move on. Positive 4 on a will give us positive 4a. Then positive 4 on negative 5, the result is going to be negative 20. And the lowest common denominator is going to be the product of a minus 5 and 2a plus 3. In the numerator, you are going to see that we have like terms. For example, 6a and positive 4a are like terms. Similarly, positive 9 and negative 20 are also like terms. So we collect the like terms so that we can simplify them. So we are going to get 6a to be written next to positive 4a. And remember, whenever you are collecting the like terms, you must make sure that each term moves with the sign it has before it. So, like the next one is going to be this 9, which is positive, so it moves together with its sign. And the 20 is negative, so it has to be written as the negative 20. This whole expression is going to be divided by the lowest common denominator, which is a minus 5 multiplied by 2a plus 3. These two must now be expressed as a single term. So we move on. 6a plus 4a gives us 10a. Then we have positive 9 and negative 20, which should be able to give us negative 11. Everything is divided by the product of a minus 5 and 2a plus 3. If you have noticed, I haven't expanded the denominator because I want the denominator to be in its factorized form, so that when I get this numerator, I must also check to see whether I can factorize it. Like I said, fractions must always be reduced to their lowest terms. So let's look at the numerator. 10a minus 11. Is it possible for us to factorize? We will see that it is not possible, so it means we have reached the final answer as 10a minus 11 divided by the product of a minus 5 and 2a plus 3. We will move on and look at another example where now either one of the two denominators or both are going to be such that it is possible for you to factorize. So let's see. So now we have an example which is 3 over b plus 2 minus b minus 3 over b squared minus 4. Let's look at the first denominator, b plus 2. Is it possible for us to factorize? When we look at it, it is not. But when we look at b squared minus 4, you will see that it is possible for you to factorize. So I'll give you a few seconds to do the factorization and see if what you are going to do is going to be the same as what we are going to get in the next few seconds. Those of you who are familiar with this expression, you are going to appreciate that it is a difference of two squares, meaning on the left of the minus sign, we have b squared. On the right-hand side, we are going to appreciate that it is a difference of two squares, meaning on the left of the minus sign, we have b squared. On the right-hand side, we have 4, which is a perfect square and can be written down as 2 to the power of 2. And whenever you are factorizing a difference of two squares, when you reach this stage, the factorization is going to come out as the product of b minus 2 and b plus 2. So those of you who got this as the solution, that's very good. And those who failed, hard luck. Next time, you will do better. So now that this denominator has been factorized, let's go back to our question and see how we can make use of it. So this fraction, which we have in our second example, will now appear as 3 over b plus 2 minus our second fraction. We have the numerator b minus 3, but the denominator is the one which we have factorized as b minus 2 multiplied by b plus 2. And like what we said when we were looking at common fractions, when we now look at the two denominators, if we have a factor which is appearing in the first one and is repeated in the second denominator, it shouldn't be captured a second time. Meaning, our lowest common denominator is going to come out as the product of b plus 2 multiplied by b minus 2. This other factor of b plus 2 is a repetition of what is appearing in the first denominator. So it shouldn't be captured a second time. So our lowest common denominator is going to be the product of b plus 2 and b minus 2. Then we proceed like the way we proceeded before. The denominator b plus 2, when divided in this lowest common denominator, the result is going to be b minus 2, which must be multiplied by the numerator 3. So we are going to have 3 multiplied by b minus 2. We close. Then minus. Our second denominator is b minus 2 multiplied by b plus 2. When it is divided into this lowest common denominator, the result is going to be 1. And this 1 must be multiplied by the numerator, which is b minus 3. Like what we did in the previous example, we now have to expand the numerator and simplify. So we proceed. 3 multiplied by b gives us 3b. 3 multiplied by negative 2 will give us negative 6. We have negative 1, which must be multiplied by b, and we are going to get negative b. Negative 1 multiplied by negative 3 will give us positive 3. Remember, when you multiply a negative and a negative, the result is going to be positive. The denominator to this numerator is, as agreed, b plus 2 multiplied by b minus 2. Then we look at our numerator, we are going to see that positive 3b and negative b are like terms. Similarly, negative 6 and positive 3 are also like terms. So we collect the like terms and simplify. So we are going to see that 3b must be written next to negative b. Like I said, make sure that each term moves together with its sign. Then we have negative 6, which must be written next to positive 3. When we do that, it means we would have collected the like terms. Of course, the numerator has been done. The denominator is going to be b plus 2 multiplied by b minus 2. Then we get to simplify the numerator. 3b minus b will give us 2b. We have negative 6 plus 3, which is going to result into negative 3. And this must be divided by b plus 2 multiplied by b minus 2. And like I said, you must always ensure that the fraction is reduced to its lowest terms. So you look at the numerator and check as to whether it can be factorized. So that if it is factorizable, and in the numerator you have a factor which is the same as another factor in the denominator, the two of them have to divide so as to have the fraction reduced to its lowest terms. But in this case, we are going to see that 2b minus 3 is not factorizable, meaning this is going to be our final answer. So whenever we are dealing with addition and subtraction of algebraic fractions, the few things that we need to bear in mind is to look at the denominators. If the denominators, like was the case in the first example, are not factorizable, then the lowest common denominator is simply the product of the two denominators. But if you have a situation like the one we have in the second example, where either both or one of the two denominators is factorizable, you must start by factorizing the factorizable denominators. Then, in the product of the lowest common denominator, you must avoid repeating factors that were appearing in the first denominator, which are now appearing in the second denominator. And after all is done, at the end, you must ensure that you check if the numerator is factorizable, so that if there is a factor in the numerator which is going to be the same as a factor in the denominator, then you need to divide both the numerator and the denominator by that common factor, so that the algebraic fraction can be reduced to the lowest terms. At this point, I'll give you a number of algebraic fractions which I would want you to express as single fractions, or which you must be able to add and subtract depending on the instruction. Having looked at our lesson, following are the questions that I would like you, dear learners, to have a go at. Express each of the following as a single fraction. The first one is a over 3 plus b over 2. The second one is c over 4 minus 5c over 6. The third one, 7 over 2d minus 5 over 3d. The fourth one is 4 over 3r minus 2 minus 3 over r plus 5. The fifth one is 2m minus 5 over m minus 2 plus m over 2m minus 4. The sixth one is 3 over a minus b minus 4 over a. The next one is b over 2b minus 1 plus 4 over 5. And lastly, we have 4x minus 7 over x squared minus 3x plus 2 minus 3 over x minus 1. And like I said, for each one of them, check for those hints which I gave. Look at the denominators. If they are numbers, check, are they prime? If they are prime, then the product of the prime numbers will give you the lowest common denominators. If they are not, express the denominators first and foremost as the products of their prime factors. When it comes to denominators that are algebraic expressions, check if they are factorizable. If they are not, the product is simply going to be the lowest common denominator. But if they are, start by factorizing. And when writing down the product for the lowest common denominator, make sure that you don't repeat factors that are in the first one that are repeated in the second one. Having given you the questions, let me now give you the expected solutions so that after you have solved the questions, you check as to whether you have done the correct thing or not. The expected solutions are as follows. For the first one, I expect you to get 2a plus 3b over 6. The second one, negative 7c over 12. The third one, 11 over 6d. The fourth one, negative 5r plus 26 over the product of 3r minus 2 and r plus 5. The fifth one, you should be able to get 5 over 2. The sixth one, you should get negative a plus 4b over the product of a and a minus b. The seventh one, you should be able to get 13b minus 4 over the product of 5 and 2b minus 1. And for the last one, I expect you to get 1 over x minus 2. My dear learners, thank you for your attention and thank you for your time. I hope you enjoyed the lesson. Until next time, from me, Makubalo Frederick, it's bye-bye.